Good evening, all. I welcome you all to this Advanced Concrete Technology NPTEL course live session. So, every week we'll be meeting on Monday evening from 6 to 7 p.m. So, let me move to the live session. Let me move to the solving of practice questions. So, uh, here I'll be solving you some 8 to 10 practice assignment questions, so which will not be your current assignment questions. So you'll have an idea to how to solve the practice questions. So it will be from the particular week. If it's going to be a week 1's live session, then I'll be solving practice assignment questions from week 1 content. So let me share my screen now. I hope my voice is audible as well as the screen is visible to everyone. So this week is going to be a trial session. So the course instructor for this Advanced Concrete Technology course is Professor Nilakanmani from IIT Madras. So I am a research scholar working in the area of utilization of biomass ash, and I'm a PhD student at Indian Institute of Technology Madras, Chennai. So here is the first question for you. So you have to find the answer for this question, and I request everyone to not type the answer in chat box so that you can enter the answer in the polls. Let me introduce you how to use polls. Just a minute. So here I request everyone here to the bottom right corner of your screen, there you can find activities in your desktop, or else if you are using a mobile phone, there will be 3 dots. No? If you click that, you can find the option called activities. So if you click that, there will be 4 options for you: breakout rooms, polls, question answer, whiteboarding. Out of that, you have to click polls. In polls, you'll have right now I have taken 8 questions for this try run, so that you can give your answers here. So the first question is nothing but as per IS 269, a maximum of percentage by mass can be added as a performance improver in plain Portland cement. So what is the maximum percentage of performance improver can be added to plain Portland cement, which is nothing but ordinary Portland cement. So you guys can give your answers here. So I have similarly I've added 8 questions. Right now we can you can give your answers for question 1 only. While moving on, you can give the answers. So here the question is, as per IS 261, maximum what will be the maximum percentage? I'll give you 1 minute time so that you can give your answers. So after that, we'll see the explanation for this answer. Okay. So as of now, no one has given answers. Okay. So now I'll be giving the explanation for this question. In IS 269 IS code, they have given few what are the modifications they have made it. In that, they have mentioned requirement of insoluble residue has been specified as a 5% maximum, irrespective of addition of performance improvers or otherwise. So the maximum performance improver can be limited only to a 5%, which should not be exceeded further. Then, so the answer is option C. I hope you got the answer. Now let's move to question 2. So in question 2, the question 2 is, which of the following materials are not added to the kiln in the manufacturing of ordinary Portland cement? So we all know that what are the raw materials for cement manufacturing. So if you know the answer, you can give it directly, or else I can help you guys. So we know that for manufacturing ordinary Portland cement, we need calcareous material. That primarily it is a calcium carbonate limestone. It will have some impurities, but it should have a calcareous material. And then argillaceous material, it should be a mostly it is a clayey matter, so it should have sources of silica as well as alumina. And then gypsum is also is a raw material which is added in the final stages of manufacturing, which is used as a set regulator. And then performance improvers up to 5% can be used. Okay, so and we know that coal is nothing but a fuel to fuel added to the added to burn these materials. Okay, so the question is, which of the following material is not added to the kiln? Okay, kiln is the area where it is burnt to a respective temperature to prepare the ordinary Portland cement. So you have to find the answer which is not added to the kiln. So I hope you got the answer. You can give your answer in quotes. I can check the response. So the answer is nothing but gypsum. It's not coal because gypsum is added once the clinker is formed in the kiln. It is moved to the cooling chamber where it is cooled to form the clinker. So in that, gypsum will be added once the clinker is formed. So it's not added to the kiln. Okay. So the answer is option D, gypsum. Moving to question 3. The temperature required for the manufacturing of ordinary Portland cement in the kiln. So now you have to tell the answer for what is the temperature required for manufacturing OPC. So I hope you guys know the answer. Anyway, I'll show the figure so you have an idea what is the answer. So here is the schematic showing the temperatures of the different zones in cement manufacturing. So at what temperature what kind of process happens. So less than 50 degrees Celsius, like from 50 to 600 degrees Celsius, mostly in the range of 100 degrees Celsius, free water will evaporate, and similarly followed by clay decomposition, limestone decomposition, formation of the phases. So what is the maximum temperature attained in the kiln? That is the question. So you can give your answers in polls. I'll wait for 1 minute so that you can give your answers. If you guys have answered in the polls, so if you guys are not able to find or not able to answer in the polls, you can give your answer in chat box as well. So moving here, the answer is nothing but 1500 degrees Celsius, which is shown in the figure here. So it's in the range of 1450 to 1550. So the feeder temperature and the gas temperature will vary. So it will be in the range of 1500 degrees Celsius. So the answer is nothing but option C. And the fourth question is, what is the Blaine's fineness value for OPC? Typically is in the range of. So here they are asking what is the Blaine's fineness. So I hope you guys know the answer. It's very direct. So you can give your answers in polls as well as chat box if you're not able to answer in polls. So what is the typical range? So the answer is nothing but option C, 300 to 500 meters square per kg. So that is the Blaine's fineness value for typical OPC. Okay. So moving to question 5. In sulfate resistant cement, the particular amount of phase of cement is restricted. We know that there are 4 types of bogus compounds, which is named C3S, tricalcium silicate, and tricalcium silicate C2S, and then tricalcium aluminate, which is nothing but C3A, and then tetracalcium aluminoferrate. So out of these 4 phases, which particular phase is restricted for sulfate resisting cement? Okay, so let me help you guys. So this is a typical composition of type 1 to 5 cements according to ASTM classification. So here the type 5 belongs to sulfate resisting cement. So here you can see which particular phase is limited. You can compare it with type 1 so that you can have an idea which particular phase is limited. I hope you guys got the answer. You can give your answer in polls or chat box. So moving to the answer is nothing but C3A. So we have to limit the tricalcium aluminate phase because whenever there is excess alumina, and if, it will continue to form monosulfate phases. So because in sulfate resisting cement there will be additional source of sulfates to the from the surrounding environment to the cement, hardened cement phase. So what happens is once there is still alumina available in the system, if additional sulfate comes, it can form ettringate kind of phases, which is expansive in nature. If ettringate type of phase is formed in a hardened cement phase, then it will exert some pressure because in hardened state it will the expansion and volume will induce stress in the hardened cement phase, so which is not helpful. So we'll limit the percentage of C3A phase in the cement. So the option is nothing but answer is nothing but option C. And moving to question 6, the age at which complete hydration of cement happens in a normal strength concrete is. So they're asking complete hydration. When the 100, when if you take 1 gram of cement, when that 1 gram of cement will completely hydrate? That is the question here. So there are 4 options here: 3 days, 7 days, 28 days, none of them. It's kind of a tricky question. So you have to think and answer. You can give your answers in polls as well as chat box. If you have any doubt in between, you can unmute yourself and ask any questions. So the answer is nothing but none of the above, because if if you take a normal strength concrete, generally the water to cement ratio is in the range of 0.5 to 0.4 to 0.6 in the range. Okay, so in that particular in that particular range, so what will happen? If you keep on curing the cement concrete, it will keep on hydrating. You can check long-term strength of the concrete, so it keeps on rising. So which means that if you supply additional water, it will keep on hydrating, which means that a complete hydration of cement is kind of an asymptotic curve, so it keeps on hydrating. So the answer is none of the above. Moving to question 7. The modulus of elasticity of concrete as per IS 456 can be correlated to the characteristic strength of concrete. This is a very direct question, which is from IS 456 code. I hope everyone knows the answer. You can give your answer in chat box. It is a particular, it's an empirical equation. What is the modulus of elasticity of concrete? You can say it as a normal strength for, what is the modulus of elasticity for normal strength concrete? That is a proper way of questioning this. So it is nothing but E is equal to 5000 root of FCK. So the option is nothing but option B. I hope you guys got the answer. Let me move to question 8. The recommended maximum cement content as per IS 456 to avoid cracking due to drying, shrinkage and thermal effects. So here they are asking what could be the maximum cement content that could be limited, which excludes slag and fly ash. So we can exclude the pozzolanic material. Excluding that, what can be the maximum cement content as per IS 456 to avoid drying, shrinkage and thermal effects. So this is also kind of direct question. You can give your answers in polls as well as chat box. So from IS 456 we can say that it is limited to 450 kg per meter cube. The option is nothing but option C. So if you keep on increasing the cement content, so there will be more fine material in the system, so there will be drying shrinkage and then there will be thermal shrinkage as well due to excessive amount of heat generated because of the higher amount of cement content present. So I hope you guys find it interesting to solve this practice assignment question, so which will be helpful for you guys to solve this particular week's contents assignment. So if you guys have any doubt in the questions posted, you can raise your questions. You can type in the chat box, as well as you can unmute yourself and raise your questions. And if you further have any more doubts regarding this particular week content, you can unmute yourself and ask. If I'm able to answer, I'll give answer in this particular live session, or else I'll give the answer in next live session. If you have any other clarification or something also, you can unmute and ask. So let me stop sharing my screen. I hope you guys found it interesting to use this option code. So usually it's in the bottom right corner of your screen. There is an option called activities. If you click that, there will be 4 options. Out of that, you have to click polls to give your answers. Okay, fine. Let me end this session here. Thank you all. Thank you all for your patience.